Engineering College. I welcome all the participants and our session chair in this third international conference on recent trend in renewable energy and advancement in engineering and technology, Rtreaet 2023, which is sponsored and catalyzed by Rtreaet, Government of Haryana. Today, our session chair is Dr. Siraj Kirmani Saab, who is Associate Professor in Department of Electrical and Electronics Engineering, Department of Electrical Engineering, Aligarh Muslim University. Dr. Kirmani Saab obtained BTech from Jamia Millia Islamia, MTech from IIT Delhi, and PhD from Jamia Millia Islamia. Dr. Kirmani Saab has also served the Jamia Millia Islamia. Now he is in Electrical Engineering Department, AMU. Dr. Siraj Kirmani Saab has very wide research in the field of new and renewable energy. He has published more than 50 papers in reputed international journals like Transaction and Triple Axis. So, and he has also published the books on renewable energy. So I welcome our respected session chair, Dr. Siraj Kirmani Saab, in this third international conference, and the co-session chair of this international conference in the first day and afternoon session is Professor Sudhir Davra Saab. So I hand over the mic to our respected Professor Sudhir Davra Saab. Please start the session, or the first session of this conference. Davra Saab.
Dr. Sudhir Davra Saab, are you there?
Yeah, good.
So maybe he's on the way. He's just joining us.
Okay, then Dr. Junaid Saab, I think, is there, so he can start.
Dr. Junaid, are you there? Dr. Shahid, please ask Dr. Sudhir Davra Saab to join.
Junaid Saab, you have the list of paper presenters.
Junaid Saab is also, I think, not joined in.
Dr. Shamshad Ali, am I audible?
Yes, sir. Yes, sir. Welcome, sir. Dr.
Well,
Siraj Kirmani Saab, you are welcome. And you are very much audible.
yeah. So what I can suggest is that we can start the paper presentation. Meanwhile, the guest will
Davra Saab
join
will
in
join.
between.
Okay, sir. Okay, but Junaid Saab, you have the list. Who has the list of the paper presenter? I think Shahid Saab, you have given this list to Davra Saab.
Yes, Davra Saab has just joined. He is around.
He is around. So from the list, we can call first paper presenter. Teaching group का
A very good afternoon. This is a post-lunch session, and I welcome all the participants. The first paper ID is 1039, and it has to be presented by Mr. Ankush Kumar, and the topic is renewable energy and emerging technology towards climate change, India's perspective. So I may request Mr. Ankush Kumar to present the paper. Mr. Ankush is there. Mr. Ankush. Okay, might be he is not in a position to connect right now. We are moving to the next participant, Jishan Ahmed, and the paper title is, paper ID is 1047, Recent Trends in AI-based Optimization and Control in Electric Vehicles.
Hello, good afternoon. My screen is visible. I'm sharing the
Please
screen.
speak loudly. Your voice is a bit low.
Is my screen visible to you?
Yeah, it's visible. Please start. Please continue.
Jishan sir, your voice is very low.
Your voice is clear, sir. I think there is problem on your side.
Okay. So good afternoon to all of you. My name is Zishan Ahmed and I'm electrical engineering final year student at Mecw Engineering College. A very warm welcome to all the participants and panelists. I always feel gratitude to Mecw Engineering College. Mecw Engineering College is going well successfully in its third international online conference. Today, I'm very much excited and happy to be the part of this beautiful program, beautiful platform, which is for the researchers, students, and teachers. Today, I'm presenting recent trends in artificial intelligence-based optimization and control in electric vehicle. I'm proceeding with my first slide, which is introduction part. So when we talk about electric vehicle, we just must compare it with the conventional forms of vehicle. So while talking about conventional vehicles, fossil fuels that directly hit to us, at this point of time, there is already very much limited supply of fossil fuels. Despite being limited availability of fossil fuels, it is also responsible for the different consequences, especially climate-related problems, geopolitical tensions, and health risk issues. So it becomes very important to transit towards the renewable and cleaner energy sources, which is solar, wind, and geothermal. And this is the only solution to our associated problems. When we talk about electric vehicles, so it primarily focuses on its environmental advantages when compared to conventional vehicles. And these electric vehicles have very significant roles in terms of air pollutants reductions, greenhouse gases emissions, and it also contributes to energy security by reduction in oil imports. We should know that India is the third largest oil consumer after United States and China. It nearly imports 84% of crude oil. So we can understand the severity here. Coming to the electric vehicles, so new charging infrastructure, awareness of electric vehicle, environmental benefits, certain kinds of incentives for the purchaser of EV vehicles. This has, of course, got some popularity and has got some adoption of electric vehicles, but at the same time there is certain limited range, certain limitations are also there that could be especially lack of charging infrastructure, high cost of electric vehicle, battery performance related issues that must be noticed. So as my title is related to artificial intelligence. So several attractive examples of artificial intelligence that might be include. I have mentioned certain points here like EV cost reduction through optimal battery material design and manufacturing. So in the case of optimal battery material design and manufacturing, if it will definitely reduce the overall electric vehicle cost. And the second thing is accurate range estimation to mitigate EV consumer range and anxiety by predicting future driving conditions. The third one is improved electric vehicle energy consumptions versus traditional controls using artificial intelligence controls for the EV auxiliary systems. And potential for increased road safety and optimal traffic flow through connected and autonomous driving. Yes, it is already implemented also, like there is autonomous car So these autonomous vehicles give a kind of optimal traffic flow. It also gives a safer side of the road accidents and all. Similarly, a thorough and efficient modeling approach for optimal locations of electric vehicle charging stations. So these are limited areas. These are the areas where artificial intelligence has a great contribution. I have mentioned certain points where artificial intelligence has in like electric vehicle battery design, manufacture, management, range optimization, EV control system design and optimization. Now, it is not possible that we can skip charging stations when we talk about electric vehicle. It becomes very important to talk about the charging stations infrastructures when we have a discussion when we talk about electric vehicle, because it is like milk for babies. One cannot survive. One cannot imagine that a baby could survive without feeding milk. At the same time, this electric vehicle industry could never boom unless and until we have a proper infrastructure for the charging stations. So there are several factors which are related to these charging stations establishments that could be like local charging demand, and that could be road connectivity and other infrastructures. Other infrastructures could be like supply of electricity to that area, construction feasibility, like how much the construction is visible, operating economy, and power grid security. Being very specific, further optimal location placement. So with the help of data analytics, including the use of machine learning, it could be like a better electric vehicle infrastructure could be planned. Secondly, data collections, data pre-processing, these existing electric charging stations, its efficiency could be improved. The next thing is energy scheduling and congestion management. So energy scheduling and congestion management is two very important aspects. Energy scheduling is like a kind of action plan which gives you the idea about like this amount of energy we have, and this is the need, or this is the demand, or this is the consumer's need. So this energy scheduling basically save us from energy waste and avoid us from blacks out and brownouts. Blackouts and brownouts are the two technical things. Like blackouts is the situation where there is complete loss of power, and brownouts is a situation where there is partial loss of power. Second thing is that congestion management. So congestion management is a kind of balance to the supply and demand. So these both two things can be ensured with the help of artificial intelligence. Talking about batteries. So batteries are the core component of electric vehicles, and at this present time, lithium ion battery has a very remarkable contribution in energy storage and power source to electric vehicles. But at the same time, there are still some performance related issues that exist, starting from barriers in battery design to its manufacturing management. So these limitations lead to the lower energy density of the battery pack, which ultimately increases the cost of the battery. So at the time of manufacturing or during manufacturing, it is important to ensure that the battery's energy density is close to its maximal theoretical limits. Uh, the next thing is machine learning in BMS, that is battery management system. So battery management system, BMS plays a very vital role because it monitors the battery pack senses and straight emissions of the battery, and it also ensures the efficient control of the battery pack. So in that approach, where machine learning in the combination with the with the higher SOC and SOH predictions, so it gives us the accuracy and low computational resources requirements. Similarly, machine learning in range optimization, where artificial intelligence algorithms, including machine learning, can be used to accurately predict the future environment and driving conditions, which is based upon the previous and the future conditions. Now, there is two things. Now, the next topic is artificial intelligence, the integration of EVs with the smart grid. So there are the two things, G2V and V2G. So G2V is like grid to vehicle and V2G is vehicle to grid. So the direction of energy flow from the grid to EVs is referred as G2V, while from vehicle to grid is referred as V2G. So in the case of EV charging, V2G vehicle to grid is in opposite energy flow. Therefore, in the case of taking the smart grid perspective, electric vehicle can be viewed as an energy storage in the format of G2V. And similarly, it could be energy generated during its discharge, that is V2G. So this is also one of the attractive features, and this could be also like energy generation to the grid, which can be a revenue stream for the EV owners. But at the same time, there are so many limitations like social resistance to VDG, V2G, energy distributions, complications, hardware barriers are there, and high investment costs are there. So, in nutshell, I can say artificial intelligence can be used as an effective tool. Especially artificial intelligence algorithms can regulate energy scheduling and optimization problems. Now, the next slide is research trends. So there is no doubt that artificial intelligence has this capability to revolutionize the electric vehicle industry in coming future. At the same time, there are so many research trends available to this field. Few of them I have listed here, like artificial intelligence in battery management system, where charging and discharging of the batteries can be monitored, can be optimized. At the same time, the longer life of the battery can be ensured. So this will definitely help in reducing the cost of the battery replacement. Another trend is the use of artificial intelligence in autonomous driving, that is self-driving car. So as a autonomous driving, artificial AI-based systems, so it gives a very convenient kind of driving experience, and it is also safer because AI-based vehicle has sensor, and it has the capacity to detect the things which is backside of the car, which is front side of the car, left side of the car, right side of the car, which sometimes become impossible for the man or for the human driving the car, which results to the certain kinds of road accidents and all. So these are some research trends available to to this industry. So I'm proceeding towards the conclusion thing. So in conclusion, I would like to say that artificial intelligence has this potential to improve the performance and efficiency of these electric vehicles. However, it is very important to note that implementation of artificial intelligence, implementation of AI in electric vehicle is in its early stage. This is the early stage of its implementations. And many research and development things are very much needed in order to fully realize its potential, to fully realize the potential of AI in EV. Overall, the integration of AI in EV has the potential to significantly improve the overall energy efficiency and the sustainability of transportation. So in this way, I wind up my presentation. And thank you so much to the organizers, and thank you so much to all of you.
Thank you, Jishan. Any question from the audience? Okay, Jishan, thank you so much.
Thank you, sir.
One thing, मेरी आवाज आ रही है ना? Hello?
Yes, sir.
Ishan, are you able to hear?
Yes, sir. Yes, sir. You are audible to me.
My suggestion is that since you are an undergraduate student, so
Yes.
while you have to, while presenting or while making the slides, you have to write in bullet points. Okay, do not have to write so much in one slide. Like you see your first slide, it was so much crowdy.
Okay, sir.
Okay, so while
Noted,
presenting, you have to be, you have to present in the bullet form.
Noted, sir.
Okay, thank you.
Thank you very much.
Okay, sir. Thanks a lot. The next paper ID is 1049, a review of concentrating solar power collectors and their performance by Wasim Akram, Mohammad Parvez.
One important thing is that Dr. Shaheen, or who is coordinating, let me check. You give some time, 10 minutes to the presenter. Otherwise, one paper has taken half an hour. It would be, if you see the 6 or 7 papers are there, it would take 3.5 hours.
Okay, sir.
Okay, sir. Thank you for suggestion. Yes.
Okay.
Next paper ID is 1053, solar powered electric vehicle by Arshi Akhtar and Mohammad Junaid Khan. Arshi, are you there? Next paper title is solar powered electric vehicles. Paper ID is 115 by Sarfaraz.
Yes, sir, I'm available here. Yeah, I'm here.
Okay, Sarfaraz, please present your paper and please share your screen and try to wind up your content within the time limit, that is 10 minutes.
Okay, yeah.
लाइट जलाता ना देखने मस्त नहीं देगा
Sir, my screen is visible. Hello.
Yes,
Everyone.
Yes, please.
Yes, sir, my name is Sarfaraz. I'm a research scholar at YMC University, Faridabad, and I am former student of BTech in Mecw College, Palla in Rtreaet department. My paper is on. First of all, I would like to thank to the director and the presenter of the this retreat to give us such an opportunity to present our papers on this level. So my paper is on solar powered electric vehicles. So here are the some parental outlines of from my side, from my papers, introduction and so on. Here is the introduction. I would like to tell about the what is solar powered electric vehicles here. Why we need solar powered
पेपर
electric
नॉट
vehicles.
शो प्रेजेंट योर पेपर स्क्रीन शेयर है ओपन नहीं हो रही फाइल नहीं ओपन हो स्क्रीन तो शेयर है
Sir, my voice is visible.
ओपन
Audible,
कर रहा है
sir.
वो ओपन नहीं हो रही शुरू हो रहा है
हो गया है मेरे ख्याल से।
शेयर तो हो गया
Sarfaraz, your screen is not shareable. Please check at your end.
screen is able but paper is not
Actually, your presentation is not coming. Please check at your end.
Okay, sir. Actually, I will connect within 2 minutes. Please, I will check it. So I will. I need only for 5 minutes to check it again. Please, sir. You can proceed with the next presenter.
Okay, Sarfaraz, thank you. And next paper ID is 1095, brief review and study of small scale grid tied solar plants by Mohammad Akib Khan and Tazim Ahmad Khan, Mumtaz Khan. Mohammad Akib Khan.
Yeah. Good afternoon. Am I audible?
Yes, you are audible.
Yeah. A warm welcome to all the dignitaries, my respected professors, my director of my esteemed institution, Rafi sir, and all my fellow students. I am Mohammad Akib Khan, currently the student of BTech EEE final year. I would like to extend my gratitude to my professor Tazim sir, Mumtaz sir, and Junaid sir for helping me out in this study of a solar PV plant. I will just quickly run through the presentation. Is my screen visible?
Yes, your screen is visible. Please try to wind up within the time limit, and your time limit is 10 minutes.
For sure, sir. Yeah. So that's the topic of the presentation, and the topic of our paper is the brief review of us and study of a small scale solar power
Please
plant.
run the slideshow. Yes, Akib, thank
Is
you.
it visible?
Yeah, it is visible. Clearly visible.
Yeah. So the topic of our paper is actually the brief review and study of a small scale grid-tied solar PV plant. A small scale grid-tied solar PV plant lies somewhere in between 1 kilowatt to up to a 500 or 600 kilowatt solar plant. So the presentation starts with a very basic question: what is exactly a solar system? So a solar PV system is actually type of a regular power plant which generates electricity by using the fuel as a solar. So why we want to go to solar? Because see, the world today is facing the harness effects and adverse effects of the climate change. So to reduce the earth's temperature and to fight the climate change, solar power system and renewable energy can be a best alternative. So why to go solar? Because this source of energy is constantly replenishable. We can easily capture it. It is also a pollution free and maybe the cheapest power that is available today. So this is a brief depiction of how exactly a solar plant works. I try to actually commercialize it, and you can actually see the plant is installed at a house where the solar panels are placed on the rooftop. The sun's energy is falling into them. It gets converted through the effect of photoelectric effect. Now the electricity that is converted from solar plant is actually a DC power. So we need to convert it to the AC by using an inverter. We can see, so that once the inverter is used, the power gets converted So this is a brief scenario of the solar PV plant in India. Currently, India is the third largest nation in terms of consuming the electricity after China and United States. As the government, the central government has set an ambitious target to achieve the net zero by 2070, I believe that renewables is going to be playing the most important role. And the country is continuously targeting to achieve 450 gigawatts of installed solar in renewable capacity. Out of this 450 gigawatt, 280 gigawatt is to come from solar. So I have just tried to depict some of the leading states of the country in terms of solar installation. As you can see, Rajasthan, Gujarat, Tamil Nadu, Karnataka, Andhra Pradesh are some of the states that has the most solar capacity installed. So this is a brief overview of what a solar plant comprises of. So basically, solar plant is not a single component. It is an integration of several components that work together in synchronization and harness the sun's energy. So a basic solar system, a typical solar system consists of the solar panels, mounting structures, solar inverters, battery and charge controller in terms of in case of off-grid system, and metering panel. Metering panel comes in picture where we install solar in the industries, and cables and accessories and sensors and monitoring system. This is a overview of a typical characteristics of a solar cell, or you can say solar panel. So basically from this graph that we can see, we can observe few important characteristics, and these are the operational conditions for solar panels as well, solar cell. So this open circuit voltage can be depicted from there. Short circuit current, open circuit is the maximum voltage when there is no load. Short circuit current is the maximum current that can be obtained. Maximum power point, that is Pmax, also can be obtained from this graph. Fill factor can be obtained from this graph, and the conversion efficiency. So these 4 points are actually called the electrical characteristics of a solar panel. Apart from the solar electrical characteristics, a solar panel, a solar cell consists of the mechanical characteristics also, like the weight of the panel, dimensions of the panel, and what sort of a material is used to harness the cells in the panel. We also did a study of the performance evaluation because it is important to know the performance, how the plant is performing. So there are several factors which are involved in the performance evaluation of a solar plant. Whenever to stay on factors the evaluation of the actually orientation of module. The orientation means where which angle we are actually placing the solar panel. The latitude of the location, that means the location where the plant is installed. Temperature of the cell. If there is a shadow casting objects nearby, it may render the actually the sun's radiation and it may affect the generation of the plant. Efficiency of solar plant is another factor. Solar irradiance is nothing but this power density that is coming from the sun per unit area of the panel. Climatic condition like clouds, winds, and rain can also affect the performance evaluation. Operation and maintenance, and lastly, the workmanship and the installation practice, how you install the plant also impacts the generation. So this is a typical data and a plant that is installed in somewhere in Rajasthan in place. So we actually analyzed the plant for a period of almost 2 weeks, and we found this data. That plant is generating what sort of generation we are getting on 25th January, 26th January, and so on. And this is against the performance ratio. Performance ratio is a very important factor that plays the important role of the quality of a solar plant. So you can see the performance ratio is also measured into this. So all this data is actually measured through a SCADA system, supervisory control and data acquisition system. Wherever a solar is installed, a supervisory control and data acquisition system is installed. So you can actually monitor the plant data and generation data. So this is actually the conclusion that this world is facing the climate change, and the renewable energy is the best alternative. Though, but it is also at a cost of a very high upfront investment. Whenever you need to install a solar, you may need to bear actually a heavy investment also. And this storage system, a battery backup system are also quite expensive. So a major drawback that we can say that solar panels do not work at night, because unless the sun is there, the solar will work then. Once the sun sets, the solar will stop working actually. So solar panels cannot be installed on every type of roof. That is another drawback of the system. And additional area is required because solar cannot be installed everywhere. It must be a shadow-free area where you need to install solar. So the temperature of Earth is constantly rising. So because of the overuse of fossil fuel, the coals and petroleum, so we need to actually shift our power dependency from this brown power to green power. And we can today together make this Earth a better place to live, and we can fight the climate change. These are the references of a few papers cited during the entire study. And this brings me to the end of the presentation. I would like to invite
हेलो, आवाज आ रही है मेरी? Are you able
Yes, sir,
to
you
hear
are
me?
very much audible.
So
Yes,
I
yes,
just
sir, you are
want to
very much audible.
try to include some data also, some comparison type of data.
All right, all
Uh,
right.
that would make the paper and the presentation more, you can say, effective. If you have a
Okay,
comparison
okay.
type of data, for example, in 1 year in one city, in for example, Nu, the automobiles that were running with diesel or petrol was causing so much of pollution. And if
Right.
electric vehicle or some is there, then that would be the amount of reduction in the carbon footprint. Something like that, if you can include, then that would make the presentation more effective.
Absolutely, sir. Absolutely. Thank you for the suggestion, sir.
Okay.
Hello. Hello. Hello.
जी सर, आवाज आ रही है आपकी?
जी. Assalamu alaikum and very good afternoon. Thank you so much for inviting me to present this paper. I would like to welcome Dr. Siraj Kirmani Saab also and the organizers for organizing this beautiful international conference. I am presenting a paper on the review of concentrating solar power collectors and their performances. In the introductory part, as we all know that the concentrating collector is a variation of the flat plate collector to increase the amount of solar radiations which are reaching the absorber. As far as this design is concerned, it can increase the amount of solar radiations by a factor of up to 10,000. In a solar thermal power plant, solar heat is collected, which is used to increase the temperature of the fluid in a turbine, which typically operating on a Rankine cycle, which then generates electricity. As we all know that we all are looking for some alternative source of energy because coal is getting short and shorter day by day, and we are facing acute challenges. So we see solar power plants and other renewable source of energy as a potential source of energy which can fulfill the demand of this universe. A lot of solar energy is available on the earth, but its distribution is not evenly distributed due to the location of the various regions around the equator. As far as the sun is concerned, it provides an average of almost 300 annually, which translates approximately this much of amount per day, which is enough to meet the energy needs of the whole humanity in a year. While solar energy conversion is often associated with photovoltaic cells, there are other methods also for generating electricity from sunlight, such as concentrating solar powers. CSP technology is a promising solution for meeting the growing energy demands of emerging and developing countries and can play a significant role in industrializing nations' transitions to renewable energy on demand. The concentrators of the CSP system uses reflective facet to focus solar energy and directs the concentrated energy to the receiver. The concentrator is composed of a combination of reflectors, structural elements, and a one axis for parabolic collectors or two axis tracking system. Concentrators are utilized in CSP systems as they are essential for efficient conversion at high operating temperatures, but they also offer other benefits such as reducing the amount of costly receiver material which is required, while mirror materials which are generally less expensive than the materials which are used for the receiver. The concentrators are typically the most expensive subsystem in a CSP system. Concentrator systems present an alternative target for cost reduction. Additionally, reflectors cost make up roughly half of the concentrators cost, which is so low, mirrors are an ongoing area of research. Reflectors that are less costly, improved in optical performances, are more durable and have lower maintenance and cleaning requirements, which are highly desirable and represent key areas of the research. A concentrator can be characterized by its concentration ratio and concentrator efficiency. As far as the reflectors are concerned, the concentrator efficiency refers to the ratio of sunlight that reaches the receiver divided by the sunlight incident on the concentrator. Real systems have concentrator efficiency values that drop below unity due to imperfect reflector materials and challenges associated with varying solar elevations. The optical properties of the reflectors and the design of the concentrator are both important in achieving high concentration efficiency. I would go to the point of the power generation. The power generation of the electrical power is one of the most important applications of an energy source. Solar thermal power cycles can be classified as low, medium, and high temperature cycles. Low temperature cycles work at maximum temperatures of about 100 degrees Celsius. Medium works at around 400, and high cycles work at a temperature of around 600 degrees Celsius. Solar energy is one of the valuable source of renewable energy, and there are different ways to harness it. Low temperature systems use flat plate collectors or solar ponds to collect solar energy, while systems that utilize the solar chimney concept have also been proposed. Medium temperature systems use line focusing parabolic trough collectors are linear Fresnel reflectors, while high temperature systems use paraboloid disk collectors or central receivers located at the top of the tower. These mediums and high temperature systems are commonly referred to as concentrated solar power systems. As far as conclusion is concerned, I would like to go to the point of the conclusion. Concentrated solar power stands out as one of the very unique form of renewable energy, thanks to its availability to store thermal energy. This allows it to produce electricity on demand, acting as a reliable and consistent source of power similar to traditional baseload power plants. Additionally, the integration of CSP with thermal energy storage allows for greater utilization of other variable or intermittent renewable energy sources such as wind and solar power collectors. Also work in conjunction with fossil fuel in hybrid configurations, improving the overall performance of both systems. Researchers and scientists have spent over a decade exploring ways to harness the vast energy potential of the sun, and the CSP industry continues to innovate and improve its grid compatibility, use in hybrid system, and integration with advanced. As far as this is concerned, it increases the efficiency, because we all know that that solar energy is almost provided at free of cost, but it's so it is one of the very promising and the future world is looking. So this was my paper. Thank you so much.
One thing, is the presentation over?
Hello.
Yeah, is the presentation over?
Yes, sir. Yes, sir. Yes, sir.
Just scroll down to references also, if you have.
References, sir. Okay, sir.
Yes.
Thank you, Mr. Wasim. Is there any question from the audience side?
References are not included in the slide, sir, but I have references.
Why references are not included?
Professor Wasim, Dr. Junaid have a question for you.
Yeah, please.
Sir, if anybody interested work for the extent, so can you please provide any suggestion regarding the future work?
Can you repeat the question, Dr. Junaid Saab? First, I would like to answer डॉक्टर सिराज किरमानी साहब उन्होंने पूछा था कि रेफरेंस के बारे में. सर रेफरेंस स्लाइड में नहीं है, लेकिन डॉक्टर शाहीन साहब चाहूंगा कि आप रेफरेंस भी अगर शो कर पाएं स्क्रीन पर मेरे ओरिजिनल पेपर से सर, इफ इट इज पॉसिबल सर.
See, you must include the references in the PPT only.
Okay, sir. Noted, sir. Noted for future presentation, sir.
Second suggestion is that once again I have repeated this for the first presenter also. While you are presenting, you must write it in the bullet points only. You do not have to
Definitely, sir.
copy paste the whole sentence, because what we
Noted,
can
sir.
see in the third thing is that I have given this to the second presenter, that you must have some data to compare also, to show, to compare from where you can from where you can extract something. So these are the few suggestions. Without
Noted
that,
down, sir, with thanks.
okay. Without that, the paper is incomplete.
Noted down, sir.
Okay.
Thank you so much, sir, for your suggestions. Yes, Dr. Junaid Saab.
Sir, I have a question regarding anyone interested your work extended. So can you provide any suggestion for the future work, sir?
डॉक्टर जुनैद साहब एक कॉल आ गई थी, माजरत चाहता हूं, दोबारा रिपीट करेंगे क्या आप अपना सवाल प्लीज?
सर मैं ये जानना चाह रहा हूँ, कोई बंदा आपके काम को एक्सटेंड करना चाहे तो फ्यूचर
सर।
वर्क क्या हो सकता है सर इसका?
बिल्कुल, अगर कोई एक्सटेंड करना चाहे, और मैं तो आपको भी दावत दूंगा कि आप भी इसमें वो करें, तो इसमें फ्यूचर वर्क यही हो सकता है कि सर हम एफिशिएंसी को कितना क्योंकि अभी ये एरिया नया है और बहुत ज्यादा, खैर आजकल तो रिसर्च हो रही है, लेकिन बहुत लंबा अरसा नहीं हुआ इस पर रिसर्च होते हुए, तो एक भविष्य का एक पोटेंशियल सोर्स ऑफ एनर्जी है, तो उसमें अभी रिसर्च चल भी रही हैं, तो देयर इज अ वाइड स्कोप ऑफ फ्यूचर रिसर्च, और आई वुड बी हैप्पी कि अगर आप भी उसमें ज्वाइन करना चाहें तो।
थैंक यू वेरी मच सर।
थैंक यू डॉक्टर साहब, वेलकम।
Thank you, Professor Wasim. The next paper ID is
Thank you, sir.
Paper ID 1053, Solar Powered Electric Vehicle by Arshi Akhtar. Paper ID is 1053, Solar Powered Electric Vehicle by Arshi Akhtar. The next paper ID is 1015, Solar Powered Electric Vehicles by Sarfraz.
Hello, sir. Yeah. Hello. Is I audible, sir?
Yes, you are audible.
Actually, sir, I have some issue with sharing my screen last time also.
अर्शी को मैंने बुलाया बहुत बार, हमने बुलाया
Sir, is my screen visible, sir? Hello.
Sarfraz, your presentation is not visible. Sarfraz, your presentation is not visible. I, on behalf of organizing committee and on the behalf of Mecw Engineering College, I am so much thankful for Dr. Rtreaet Kirmani Saab from Aligarh Muslim University. I may request Dr. Saab to conclude the session so that we can move to the track 2. Thank you so much, sir. Dr. Rtreaet Saab.
Yes. The session, I thank the coordinator for organizing the session in a very conducive manner. The session was very well organized. So I thank all the presenters first, that they have given a good presentation, and I hope that this conference and this presentation will take them to new heights in the field of research and development. And I set them the best of luck for their future endeavors. I also thank the organizers of the conference, Professor Khwaja Muhammad Rafi Sahab, Dr. Shamshad Ali, Dr. Shaheen, Dr. Junaid Sahab, and all the members of the Mewat Engineering College for organizing this. Thank you very much.
Sir, one
Yes, please.
candidate Arshi Akhtar want to present the paper, if you allow.
Yes.
Okay, Arshi, please, you may please start, but be fast.
Okay, sir. Good afternoon, everyone present here. My name is Arshi Akhtar, and I am a student of Aligarh Muslim University, Aligarh. And my guidance is Dr. Muhammad Junaid Khan, sir. He is the assistant professor at Mewat Engineering College. And my topic is solar power electric vehicles. Now I am going to present about a solar electric vehicle.
Hello.
Hello, sir.
Yeah, Arshi, you student of Aligarh Muslim University in which?
Hello. Yes, sir.
Yes, sir. You are a student of Aligarh Muslim University in which course you are registered in?
Mtech Biomedical Engineering. So because I was a student of Mewat Engineering College also, and a bachelor student, and I have research about.
Okay. You may continue, please.
Okay, sir. So my page is not.
Hello, sir. Is my screen is visible, sir? I'm sorry, Sir Rtreaet here.
Yeah. Yes, sir. A solar power electric vehicle is supported with the charging cable that plug into the vehicle and into the 230-volt wall socket. And my research topic about a solar electric vehicle, and that is a very pollution-less transportation system. And this is the my solar electric vehicles figure. This is the PV panel and MPPT. This is a maximum power point tracking, current control, and inverter. And this is the electric motor, and we are using a battery also. And I'm not going to talking about the theory of all about a solar electric vehicle. I'm talking about all my calculation in my research paper. And my calculation is about all solar electric vehicles. The mass of I have only taken the assumption of all the data, like mass and speed of these electric vehicles, solar electric vehicles. Mass of the vehicles is 130 kg. I have assumed these things, and speed is 40 km/h, and the slope is 0.1, and diameter is 0.58. Battery weight is approximately 30 kg, and average speed is about 35 km/h, and the range is 50 km. Calculation about the angular velocity of the wheel I have shown in the figure also. And this is the calculation about a linear velocity 40 km/h, and the speed I have taken, this is a 40 km/h, and in 5 upon 18 meter per second. Diameter of the wheel is 0.58 meter, and the radius is 0.29. And the angular using the linear velocity, angular velocity into the radius, this is the calculation about angular velocity, and the relation about the angular speed also. And my paper is all about the calculation of the solar powered electric vehicle, about the how much it's cost, how much it's taken, about the all the components in the solar powered electric vehicles. this is the peak torque, and I have calculating using this formula mass of vehicle plus battery into the acceleration due to the gravity into the wheel radius into the slope percent, which I have shown in the above slides. So, and the power required torque into the angular velocity, I am calculating this. And this is the air resistance and calculation and the rolling resistance calculation. Calculation for the continuous power required, speed and the torque required, I have calculating there. And then power required is air resistance plus a rolling resistance, and continuous speed is average speed into the 60 divided by 2 in 2 pi radius of the wheel, and the torque required is air resistance plus rolling resistance into 60 by 2 pi continuous speed. And this is the my final calculation of the result of angular velocity is 38.3 radius per second, and the frequency is 365.59 RPM, and peak torque is 45.47 meter, and power required is 1741.5 watt. Air resistance is 278.68 watt, and the rolling resistance is 418.6 watt, and the power required is 697.28 watt, and continuous speed is 320 RPM, and torque required is 20.8 Nm. And this is the solar calculation about the how much the solar taking the power. Motor specification power is 750 watt, and the operation voltage is 48 volt. Battery specification voltage is 12 volt, and the capacity is 20, and the quantity of the solar is 4. Solar panel specification power is 100 watt, and open circuit voltage is 21.84 volts. Short circuit current is 6.11 ampere, and voltage at maximum power is 17.99 volt. And the dimension is 1152 into 66 into 34 millimeter per square. Energy calculation is shown over here. Energy consumed by a motor in 3 hours, power into time, that is 1500 watt, and energy
Arshi,
produced.
please conclude your presentation.
Okay, sir. I'm coming on my cost estimation of solar electric vehicles, that is shown over here. And this is the comparison of a petrol car and electric car and the solar electric car. This is the cost of the saving per year, that is 61,560 about electric vehicle, and the 64,260 rupees for a solar electric car. And the solar electric vehicle has a many advantages, also as a disadvantage, that is it cannot be travel in a rainy season, it cannot be used, and because of the no sunlight, and we also uses we can also use solar electric power vehicles with the super battery we can use in for solar electric vehicles, and it is also a pollution-less transportation system, and it is very helpful for our health, and thank you so for.
Okay, thanks, Arshi. Any question from the audience side? Any question from the audience side? Okay, Arshi, thanks a lot.
Thank you, sir.
We once again thankful for Dr. Shiraj Kirmani Saab from the AMU Aligarh. Sir, we are concluding the track 1. I may request you please conclude the session so that we
we have already concluded, I think, in the before this presentation. Now, I once again thank all the organizers for giving the opportunity to the presenters to present the conference and for us to chair the session. Thanks a lot. Thank you, Dr. Shaheen. Please.
Okay, sir. Thanks a lot. Thanks for your valuable time for this session. Thank you so much. Now we are moving to the track 2, that is Advanced Engineering and Science. And session chair is Dr. Syed Ismail Azad Saab from the Yambu Industrial College, Yambu, Saudi Arabia. And session co-chair is Dr. Kaleem Ahmad Qureshi, Associate Professor from the Applied Science Department, Mecw Engineering College. I may request both the session chair and session co-chairs, if they allow us, then we will proceed and call the presenter for presenting the paper.
Proceed, sir.
Yes, sir. Go ahead.
Okay, sir. Thank you so much. Now I'm calling the first paper ID, that is 1060, Body Shapes, a study on challenges consumers with blemishes with respect to body type face when purchasing clothes. Omer Khan and KD Joshi.
Good afternoon, sir. I'm audible, sir. Hello.
Yes, you are audible.
Good afternoon, sir. My name is Umair Khan, and my topic is body shape, a study on challenges consumer with blemish with respect to body type face when purchasing clothes.
Omer Khan sir, please share the PPT that is not visible. You are requested to share the presentation PPTs, please.
So now this is visible, sir?
Yes, now it is visible. Now
Okay.
it's visible.
Okay, sir.
Thank you so much.
Sir, my topic is body shape, a study on challenges consumer with blemish with respect to body type, face when purchasing and clothes. My domain is fashion technology. Introduction. Individually are tall or short, overweight or cylindrical, skinny, some possess average height and breadth. A guy should wear the clothing that complement his physics, regardless of a newest fashion and design trend. Whether the physical type of clothing may alter his appearance, the figure fault can be concealed and included via the appropriate application of color and clothing. Those who are the shorter and heavier should also wear horizontal pattern and 2 or more colors. Cloth with diagonal lines and preferable for a tall, overweight person. Additionally, they should not wear very light or loose clothing. Objective: the study aims to examine the challenges consumer with body shape face when purchasing clothes. The study aimed to gain insight into the difficulties consumers face and finding clothing that fits their unique body type and the impact on their shopping experience. Literature review. As is all, according to this study, there is a direct knowledge on the buying habits of a senior consumer. The generation is financially comfortable and has the discretion to generate the increased retail sales. Extender et al. Examined to connection between body type and fit preference using the body consumer preference for apparel advantage and consumer demographic and character. Victoria et al. According to their study, the way people dress and buy the apparel is challenging as a result of advances in computer vision and machine learning. Methodology. The research team employed quantitative and experimental method, collecting data via survey response. Target population. The study was conducted in Delhi National Capital Region since it is home to a thriving garment sector, from small family-run to tailor shop to large multinational retail chain. People from all around the country with varying body types, most of which are relevant to the research as they are engaging in less physical activity regularly. Concrete, the metropolitan center that serves as the national capital. The study primary demographic was selected from the working class in Delhi National Capital Region. All participants were between age 45 and 60. The study settled on the age span since most individuals entered the workforce in their 20s and 30s and began to see a decline in physical health in their 40s and 50s. The typical retirement age is 60, chosen as a maximum age. sampling. As a result, 239 participants made up the final sample size. The information was gathering throughout the March to May of 2022. Analysis. The survey were conducted in person. Data from survey was coded by hand to rapid performance analysis using SPSS. Strictly like frequency and percentage were utilized for respective purpose to outline commonalities. Result, it is observed the majority of the study subject, 52.7% responded yes, they face problem in ability to Western formal wear suited in the specified body types. It's observed that problem with size fit 46.9% style is not nice and 12.6% price is not justified. 4.2% and limited life is of the garment is 3.8%, where the main issue is the complaint of problem and study subject faced with Western formal wear. It was observed that problem experienced by study subject while wearing jacket Western formal wear garment are tightness on the abdomen, waist, tummy 25.5%, followed by the tightness across back, shoulder blades 11.7%, and 6.7% of the study subjects respond that tightness of the chest was also a problem associated with the wearing jacket. It was observed the major problem experienced by study subject while wearing bifurcates, Western formal wear garment and bunching of fabric in crotch area in 31.8%. Tightness on the abdomen, waist, tummy is 17.15%. Crotch length running small is 16.74%. Bottom riding and high 9.21%. Tightness in the thigh area is 16.28% and punching slipping low is 5.86% etc. In conclusion, the study result indicate that the biggest problem with the cloth is size fit. In the particular, the biggest problem with jacket are tightness on the abdomen, waist, tummy, and followed by the tightness across the back, shoulder blade, tightness on the chest. On the other hand, the biggest problem with trouser were crotch length, running small, bunching of fat in the crotch area, and tightness in various areas such as the abdomen, hip, and thigh. The participants who were willing to pay extra 10 to 15% above the price they usually pay if this problem were resolved. The studies highlight the importance of ensuring proper size and fit when designing and producing the clothing. The further studies could places and the limitation identified in this study, and a large sample size could be collected to increase generality of the findings. Moreover, the study could be concluded in the different region to see the finding hold true for the other areas. These are references. Thank you.
Is there any question from the audience side? Okay, Omer Khan Saab, thank you so much. The next paper ID is 1065, Plant Disease Detection and its Health Monitoring by Akhil Bhargav and Ajita Pathak. Plant Disease Detection and its Health Monitoring, paper ID 1065. By Akhil Bhargav, Ajita Pathak. Next paper ID is 1033. That is application of the truncated and fractional derivative to the fractional differential equations by Nisha. by Miss Nisha.
Yes, sir. Yes, sir. I'm present here.
Okay.
A very good afternoon to all the respected panelists and all the participants. I'm Nisha Katoch, research scholar in Madhav University, Rajasthan. So my topic, today's topic of the paper is applications of the truncated and fractional derivative to fractional differential equations. And the abstract of the paper is, our goal in this paper is to broaden the application of the recently introduced truncated M fractional derivative. To do this, we employed the hypergeometric functions M series, S functions, and N functions, which has a more general form than the Mittag-Leffler function, because basic function is Mittag-Leffler, and all these are the generalization of Mittag-Leffler function. This generalization was given the name truncated N-series fractional derivative. This novel derivative fulfills crucial characteristics of the integer order derivatives and generalizes a number of fractional derivatives. Finally, we arrive to solve N-series fractional differential equations analytical solution. The introduction is, scientists commonly study fractional analysis because it has so many applications in modeling practical issues. Recent investigations have shown that mathematical models derived using different fractional derivatives match experimental data more favorably than models derived using integer order derivatives. So different fractional derivative definitions as opposed to integer order derivatives might be used to various issues. Scientists discovered operators as a result of this circumstance, which has a more general form than the Mittag-Leffler function. So we used N series, which has a more general form than generalized M series, Mittag-Leffler, and hypergeometric functions. We called this generalization a truncated N series fractional derivative. This new derivative generalizes several fractional derivatives and satisfies important properties of integer order derivatives. Then finally, we obtained the analytical solution of some N series fractional differential equation. So as we all know that fractional calculus is a field that is frequently studied by mathematicians because of its many application in modeling problems. And fractional derivative definitions may be used for different types of problems. This situation led scientists to identify more general fractional operators. And with the help of these fractional operators, we can find the better approximation of the fractional differential equations. Especially in the last 6 years, several generalizations of some well-known fractional derivative operators have been addressed by many authors. So in addition to these investigations, several fractional derivative operators with many of same characteristics as the integer order derivative operator were also investigated. So I'm starting with the definition of the fractional derivative, which is given by equation 5.1.1. It was known by the name conformable fractional derivative. The alternated and truncated alternative fractional derivative for f presented by Katungumpola in the same year. So the definitions are represented by the equation 5.1 by 2 and 5.1 by 3. Here we have given the exponential function ex is the truncated exponential function. Recently, Sosa and D. Oliveira introduced the m fractional and truncated m fractional derivatives, which we have defined by the equations 5.1 by 4 and 5.1 by 5.1.5 using one parameter Mittag-Leffler function and its truncated version. All of the derivatives presented above satisfy certain properties of classical calculus, such as linearity, product rule, quotient rule, chain rule, and the rule of function composition. Besides, for all the operators given above, the alpha order derivative of a function is a multiple of t1 raised to power 1 minus alpha. In 2021, then Ilya and Sharma defined a new special function S, which is represented by the equation 5.1.6. So here we define the n function. In this paper, we have defined the n function, a new generalized special function that is defined as follows, and it is represented by the equation 5.1.7. If we put the values of the parameters like theta, gamma as 1 and beta alpha, then the above function converts into S function. And if again we put alpha is equals to 1 k factorial 1, then the n function converts into generalized M series. And by giving the various values, then this function is reduced to modified M series. If we put theta is 1, then the function converts into modified M series, where beta gamma, theta, delta, and z belongs to complex numbers, and real part of beta should be greater than 0, and the denominator parameter ci should not be 0, where alpha k in the definition represented by 5.1.7 is the Pochamer symbols, which are defined as follows. So if a j is where the values of j varies from 1 to p equals to 0 negative integer, then the series reduces to polynomial. Then we don't take the values 0 or negative values, so we take values from 1 to p. And if we put this whole parameter 1, then the n function converts into the Mittag-Leffler function. So the n series basically is the generalization of the Mittag-Leffler function. And now we give some special functions. If we in the previous slides we have given different values to the parameters, and it is reducing. Firstly, it is 5.1.12 is representing that it has reduced to the exponential function, then Mittag-Leffler one parameter Mittag-Leffler function, and 5.1 by 14 representing two parameter Mittag-Leffler function, and 5.1.15 that is three parameter Mittag-Leffler function. Then the truncated, then we have introduced the fractional derivative, and 5.2.1 represent the definition of the n series, and then definition 2 represents the fractional derivative. And if the n series is the truncated n series given by equation 5.2.1, if a truncated n series fractional derivative of a function exists, then we say that function is n differentiable. And then we have given the next we have introduced n series fractional integral. So its definition is represented by the equation 5.2.22. Then next definition is the let alpha a is greater than or equals to 0 and t is greater than a, and f is defined in the semi-closed interval at. If the following improper Riemann integral exists, then
Nisha,
for
please
alpha.
conclude it.
Okay, sir, I'm concluding. So these are the various theorems which we have proved, taken from the classical approach, and we have applied n series. Then application of n series to fractional differential equations, we have taken this linear fractional differential equation, and we have find its solution. And ultimately, this is the solution given by equation 5.2.30. And the conclusion is we can say that truncated n series fractional derivative operator can be used instead of Riemann-Liouville or Caputo type derivatives to solve some difficult problems. So our definition is also a generalization of the m fractional derivative for p and q is equals to 1. So other special functions can be used instead of the n series to define additional fractional derivatives, because the n series is a general class of special functions, and it's the generalization of Mittag-Leffler function. All future definitions may be a special case of our definition. So thank you, sir. This is all about my
Thank
paper.
you, Nisha. Is there any question from the audience side? Any question from the audience side? Now the last paper of this track is paper ID 1063, impact of body type on the process of developing clothing according to consumer preference, by Omar Khan and KD Joshi. Sir, please wind up the paper within 5 or 6 minutes.
Hello.
Good afternoon, all of you. My name is Omar Khan. Impact of body type on the process of developing clothing according to the consumer preference. Introduction. In early civilization, clothes were mostly meant to keep people warm and dry. In the 21st century, we should know that clothing does more than just keep us safe. Along with the advancement, mostly status, and abdomen. This means the clothing helps the people show that they belong to a certain group and cover the body in the right ways, shows a person who rank within a group and lets people choose their individuality and creativity. Taylor said that when a country is going through a reason, women train and to wear long dresses during the time penalty. On the other hand, hemlines to level of the bottom edges of a skirt, dress, or coat often get shorter. The paper investigates and intuitive and interdisciplinary conceptual framework based on synthesis of notion from the complete social, physiology, and symbolic interaction. The study of the clothing behavior, however, the assessment does not go into a depth of intricacy. This area is multidisciplinary character. Aim and objective. The main aim is investigate the process of developing clothing as per the consumer preference in terms of body shapes and sizes. The aim fulfills with the following object. The explore the background on sizing and grading of recent body shape and research and how the industry is using it to improve clothing fit. To discuss how many companies are using new technologies and smart marketing to better engaging the informed shopper about fit, size, and shape to understand man consumer behavior and experience while purchasing clothes. Literature review, mass customization in Indian apparel industry to provide man consumer clothes at a cost that is reasonable. Methodology, the research was quantitative and experimental nature. The study was conducted in the New Delhi National Capital Region area. The target population, the Delhi, India, the National Capital Territory, is the focal point of the planning zone known as the National Capital Region. The Rtreaet district in the Mecw state of Haryana, Uttar Pradesh are included in this scope. The study was conducted in Delhi National Capital Region NCR since it is the home arriving sector from a small family-run tailor shop to large multinational retail chains. People from all around the country with a varying body types, most of the which are the relevant to the research as the engaging in less physical activity on a regular basis. Complete the metropolitan center that the serves as a national capital. For this study, is important that the researcher be familiar with the area and live close by the subjective who are from 5 cities, towns belonging to NCR. Result, it was observed the problem experienced by the study subject while wearing jacket, western formal wear, garments, tightness, employment, waist tummy 25.5%, followed by the tightness across back, shoulder blades 11.7%, 6.75 study subject respond that tightness on the chest was also a problem across associated with the wearing jacket. It was observed the major problem experienced by the study subject while wearing bifurcates western formal wear garment while pinching fabric or fabric in crotch area 31.8% tightness on the abdomen, waist tummy 17.15%. Crotch length running small 16.75%, and bottom riding is 9.21%. Tightness in the area and in the area 6.2 punch spelling low to 5.68%. From the above table, the graph is observed that the majority of the studies subjects responsible affirmative that the trouser wrinkle at the crotch 69.5%, trouser ripples at the waist is 63.6%, trouser developed smile lines in front, crotch is 63.2%, etc. Conclusion, the developed measuring method and pattern alteration system throughout the research may be crucial in the creation of the theory on clothing sizing, body shape, as well as their engagement in organization responsible for clothing manufacturing and modification. It is predictable that the finding of this study will provide the considerable amount of the data that may be used in formulation and development of the numerous ideas on body types, production method, and alteration. The pattern modification and customized pattern system created have been proven to be foolproof and cost-effective solution to the body shape from posture and other values, which was the primary problem area that research and set out the answer. In conclusion, the research suggests the framework should be framed in order to contribute in increase the standard of production of cloth in Indian clothing industry and in the clothing industry of the other nations. There are references. Thank you.
Thank you, Omar Khan Saab. Is there any question from the audience side? Any question from the audience side? I may request any suggestion from the session chair and session co-chair to give advice on this paper.
Okay, thank you.
Okay, sir. Thank you so much. Now we move to the next paper, that is paper ID 1043, specific definite integrals related with trigonometric functions. M.I. Qureshi, Dilshad Ahmed, Shahnawaz Ahmed, Muhammad Shahid. Paper ID 1043 by M.I. Qureshi, Dilshad Ahmed, Shahnawaz Ahmed, Muhammad Shahid.
Dilshad Ahmed, are you there?
Yes, thank you so much, sir. Am I audible? Hello? Hello?
Yes, sir.
Hello,
Yes.
am I audible? Hello?
Yes, audible.
Hello? Okay, thank you so much, sir.
Dr. Dilshad, are you present there?
Yes.
You may please proceed. You may please start.
Okay. Thank you so much, sir. Myself, Dilshad Ahmed. I am working as an assistant professor in the Mecw college. Today, I am presenting my research paper. Topic is specific integrals related with trigonometric functions. Is million type main integrals, derivations, and applications. At last, million type definite integrals associated with sine and cosine functions using Laplace.
Dilshad, your presentation is not movable. Dilshad?
Hello. Am I audible, sir? Hello. Hello. Am I audible, sir? Hello.
Thank you so much. Now we conclude the track 2. I may request Dr. Syed Ismail Azad Saab and session co-chair Dr. Kaleem Ahmed Qureshi. If you allow, then we can conclude the session and move to the track 2. And I may also request Dr. Syed Ismail Azad Saab and Dr. Kaleem Ahmed Qureshi to please conclude the session for your valuable words. Thank you.
Ismail Saab?
Ji, Assalamu alaikum.
Walaikum assalam. Please conclude the session.
Like what happened to this last one? I'm not able to listen anything about the last paper about the specific definite integral. Anyway, this program is very nice. I am obliged and privileged to attend this kind of problem. I got the privilege to attend this program, and thank you very much.
Thank you. Thanks a lot on behalf of the committee members. I once again thanks a lot for concluding the track 2. Now we are moving to the track 3. Session chair Dr. Shamim Akhtar Saab from JP Institute of Information Technology, Noida, and session co-chair Mr. Adil Zaidi Saab, assistant professor from the ECE department, Mecw Engineering College. I may request Dr. Shamim Saab and Mr. Adil Zaidi Saab to please allow us to start the session. Dr. Shamim Akhtar Saab and Mr. Adil Zaidi Saab. Once again, I may request Dr. Shamim Akhtar Saab.
Hello. Hello. Am I audible, sir? Hello. Hello. Hello.
I may request Mr. Adil Zaidi, sir.
Shamim Akhtar Saab. Adil Saab, please join in.
Oh, cameraman, please.
Please continue, sir.
Thank you, Adil Zaidi Saab. Now we are calling the paper first of this session. The session is on devices, circuits, materials, and processing. That is track number 3, devices, circuits, materials, and processing. And our respected session chairs are Dr. Shamim Akhtar Saab. He is from JP Institute of Information Technology, Noida. And session co-chair is Mr. Adil Zaidi, assistant professor from the ECE department. Thank you so much, sir. Now we will proceed with the paper ID 1003, study and simulation of cylindrical effect by Mohammad Javed Siddiqui and Umar Khan. Mohammad Javed Siddiqui and Muhammad Omar Khan. Al Hamad Khan.
Yes, sir. Yes, sir. Is it slide visible?
Al Hamad Saab, your time is 10 minutes. Please try to wind up within the time.
Is it my slide
Your time
visible?
is 10 minutes.
Can you hear me?
Yes, visible.
So good afternoon, everyone.
welcome to my presentation. First of all, let me thank you all for giving me this opportunity. And my topic is cylindrical CNT FET. So as scaling of SI MOSFET approaches toward limiting value, the new alternative are coming up to overcome these limitations. So the one of the most promising alternative for bulk SI MOSFET is carbon nanotube field effect transistor or CNT FET. So in this work we simulate a cylindrical CNT FET based on simulation result. Both output and transfer characteristics are plotted and analyzed. And we also study the effect of different dielectric materials used at gate insulator and diameter dependency of the characteristic curve also discussed. So the origin, graphene. Graphene is a one atom thick planar sheet of carbon atoms that is densely packed in honeycomb crystal lattice. As we see from this figure, that direct image of single layer graphene membrane, and the red dots donate the atoms, carbon atoms. And the second picture figure shows the carbon computer generated graphene visible, showing the honeycomb lattice structure. So what is carbon nanotube or CNT? So carbon nanotube CNT are basically a graphene sheet roll up in a certain direction. Cylindrical CNT are basically made up of carbon graphene, and their chirality describe how graphene sheet is rolled up to a form CNT. CNT might be metallic or conducting depending on its chiralities. So the introduction to CNT FET. CNT FET is a CNT FET is a field effect transistor that utilizes a single carbon nanotube or an array of carbon nanotube as a channel material. So these are formed by connecting two metal electrode and the gate electrode separated by CNT FET by thin oxide film. So there are no scattering in CNT channel because of it work on ballistic transport. So why we use carbon nanotube? Because it is single wall carbon nanotube is a potential channel material for high performance logic circuits, and their mobility is around 3000 to 10,000 centimeter cube per seconds, and the confinement of charge inside the nanotube allow ideal control of the electrostatic, and it is good gate control. So the cylindrical CNT FET is basically the CNT FET that is used as a channel which is surrounded by the oxide layer, and which is by the metal contact, and the metal contact serve as the gate terminal. So there are different advantage of CNT FET, and some of these advantage are the low power consumption. It consume very less power as compared to the MOSFET, bulk MOSFET, and its mobility is also very high and with very less threshold voltages. So it is also a better control over channel formation, and there is no direct tunneling, and the gate leakage current also very less. So though we have simulate this by using the NanoHub tool, and in this simulation we consider the diameter of nanotube as 1 nanometer and the gate insulator thickness 1.5 nanometer, and the threshold voltage is 0.2 volt. Dielectric constant for gate oxide is 3.9 of SiO2. For plotting the characteristic, we have taken different direct drain current and for different gate voltages and drain voltages. So from the figure 1, we can see that the plot is between the drain current, drain voltages, which are similar to the MOSFET, in which we have different gate voltages from 0.25 to 1.5 volts. So it is basically it depends on it depend on, we can plot the other graph that between saturation drain current and the Vg minus Vt, which is straight, which are linear, and it shows that from that the spacing between two consecutive curve is almost same, which means that the saturation current show a linear dependency with Vg minus Vt, and the effect of gate dielectric constant. So for this simulation, we consider nano tube diameter 1 nanometer and the gate insulator thickness 1.5 and Vt 0.2 and Vd 1.5. So for this simulation, we can clearly say that the plot is that the saturation current increases for increasing dielectric constant, but the degree of this positive effect reduces as we go for higher dielectric materials. This means that as we going from higher and higher dielectric materials, the increment in ID respect to K reduces. So simulation results are shown in figure between dielectric constant of gate oxide and the corresponding saturation current. Effect of diameter. So the transfer characteristic for different diameter of CNT are plotted in figure 1, which shows that effect is of diameter more significant in lower region of gate bias. So, and the other one shows the output characteristic for different diameter of CNT used in channel region. So from the figure, it is clear that the drain current is more for the higher values of diameter, and the difference increases as we go from higher values of diameter. So there are some major drawback for CNT effect. So the main drawback is that the defect and failure rate at device and circuit level is expected to be much higher than the traditional CMOS. And the manufacturing CNT based circuit will differ from current practices, which conventionally silicon technology, so the fault and defect models must be revisited. And the carbon nanotube will degrade in few days when exposed to oxygen. So there have been several work done on passivating the nanotube with different polymers and increasing their lifetime. So many difficulties in mass production cost. So there are some comparison between CNT FET and MOSFET. In case of CNT FET, the switching occur by modulation of constant resistance, as compared to silicon MOSFET, which switching occur by altering the channel resistivity. So CNT FET has about 4 times higher conductance as in comparison to MOSFET, and the CNT FET is capable of delivering 3 to 4 times higher drive current than the bulk MOSFET. And the average current velocity in CNT FET is almost double that is as compared to MOSFET. So the on current performance advantage of CNT FET either due to the high current capacitance or due to improved channel transport. So the improved channel velocity for CNT FET due to the increased mobility and band structure of CNT FET. And it is a courtesy 1D ballistic transport of hole and electron. So the only forward and backward scattering is possible for holes and the electron in the tube. But the mean free path is all of order of 1 micrometer, implies that the carbon nanotube have ballistic transport capability. So the conclusion, we have presented some simulation result for cylindrical CNT FET, and we conclude that the saturation current shows a linear dependency with Vg minus Vt, that is overdrive voltage. And then we discuss about the diameter dependencies of characteristic curve, which show that the drain current is more for higher values of diameter, and the difference decrease as we go from higher values of diameter. And finally, we have discussed the effect of using high dielectric material as gate insulator, which shows that the saturation current increases with increase in K, but with increasing rate. So these are very helpful for further exploration of CNT fats. These are the references. Thank you.
Okay, thank you. Is there any question from the audience side?
या आपने कंपैरिजन किससे किया हुआ है?
Sir, bulk SI MOSFET, silicon MOSFET.
Alhamdulillah, there is one question.
Yes, sir.
Which software do you have used for the simulation of this cylindrical CNT FET?
Sir, we use online platform NanoHub.
It is which software?
So NanoHub on cylindrical
Nano.
MOS simulator.
Tool you have used?
Yes, sir.
Which tool you have used?
The cylindrical CNT MOS simulator.
Apart from this, what is your novelty in this your work?
Yes, sir.
What is the novelty in your work? I just want to know what is the novelty in your work. What is new? What you have done? These all the results have been already published. And what is the novelty which you have present? Let me know. Please emphasize on that.
Sir, we reference different papers and we conclude that these effects are basically important as we go from higher study in CNT fats.
Okay. Yes, sir.
Any question from the audience side? Okay, thank you so much. Now we will proceed to the next paper, that is paper ID 1057. The fabrication and properties of hybrid metal matrix composites study, Miss Sultana Muhammad Fares.
I am audible, sir.
Paper ID is 1057. The fabrication and properties of hybrid metal matrix composites study by Miss Sultana Muhammad Fares.
Hello, I am audible, sir.
Yes, you are audible.
Okay. Thank you, sir. Thank you.
Faris sir, you are audible, but your presentation is not
Yes,
visible.
sir. I am sharing my screen.
Okay.
My screen is visible, sir?
Yes, your screen is visible, your voice is audible. You may proceed.
Okay, sir. Okay. Good afternoon.
But please try to conclude in 10 minutes.
Okay, sir. Okay. Thank you. Good afternoon to all. I am very thankful to chair conference, our honorable director, Dr. Khwaja M. Rafi, and convener of that conference, Dr. Sahin Khan, chair of that conference, and his team. And today I am presenting a paper on the fabrication and properties of the hybrid metal matrix composites STD. And the topics are covered.
Faris sir, please run the slideshow.
Okay, sir. My slide is now, we are coming to the second slide, introduction, advantage of hybrid metal matrix composites, fabrication methods, applications of hybrid metal. So basically the composites are the material which are from one or two more materials and producing a third material which have the sustainable and good properties as compared to the single material. That is the properties are composites. Now what the composites is consist of? A material, the composites made up basically two things. First one is the matrix and second one is the reinforcement. The matrix is the base metal and the reinforcement is the secondary material, which is and third one is additive. Additive is sometimes that act as a lubrication or used for to avoid the cold welding etc. The matrix, the base material, and the reinforcement is added into the matrix according to the requirement of the properties of the materials. The reinforcement may be cemented carbides, rubber mix, carbon blacks, wood, and agriculture byproduct. And third one is our matrix. Matrix is then material into reinforcement on the for that reinforcement. We have covered that. And next one is the reinforcement. Reinforcement is today the biggest material which is embedded into the matrix and which decide the properties and qualities of the material which is used for the further machining process or for a requirement according to the material. Next one is the advantage of the hybrid metal matrix composites: high strength, that is good ductility, higher corrosion resistance, maintenance of the high strength properties at the high temperatures, no moisture absorption, high thermal conductivity, higher operating temperatures, and fatigue resistance. These are the properties. If we see why we need the composite materials, these are the basic needs for the requirement of the composite materials. And next one is the fabrication methods, how we develop. Basically, 3 or 4 methods of the fabrication of the hybrid metal matrix composites. That first one is the powder metallurgy, in which we will take the material in the powder form, and that powder form, with the help of the die and the compressive press, we make it a solid pellet, and that pellet should be centered, and after that it will be goes through a mechanical testing. And the next is fabrication methods discussed, and the solid and liquid. In the solid, we basically use the powder metallurgy, as I already discussed. In liquid state, we use the stir casting method. We take a powder and we melt at this melting temperature, and then add the reinforcement and then stir. And after that, we will pour into a die and solidify. After solidify, it will be goes through the mechanical testing. That is our die for the powder metallurgy route. That is the upper punch, that is the lower punch, and that is the ejector. And we fill the powder in that die after putting a lower punch inside it and fill the powder form. Then we apply a hydraulic pressure on the die, and the powder form into a compact. And that compact further goes for the sintering process, and after sintering process, it will be for the mechanical testing. That is the basic process for the powder metallurgy route. If you want to develop a composite through a powder metallurgy, then we use that type of the die. And next one is our liquid state processing, that is then stir casting. And that is a bowl, and that is used for a stir. And we put a powder, and that powder and will give a heat. With the help of that powder melt into a liquid state, and that liquid state will be stirred. And after stirred, or by setting the parameters, it will be poured into a die and solidify. After solidification, it goes through a testing. And next one is the pressure die infiltration process, in which we use a pressure infiltration method for fabrication of the metal matrix composites using die casting technology. Perform place into the die. After that, molten metal filled into a die and permitted to cool inside the die. It is the lowest cost process, and the basic pressure die infiltration process is shown in the figure. Suppose that is our molten metal is here, and which is a red color, and inside the die we apply a pressure with the help of a plunger or a particular hydraulic press arrangement, and that fill into the die, and that covered with solidify, and after solidify it will be removed from it. And that type of the process is low cost, and easily we can fabricate that. Gas pressure infiltration process. With the help of the pressure of the gas, we can also develop the composites or a pellet, and that is type of arrangement we use here. That is in our Molten metal is here, perform is here. After that, we'll perform that matrix, metal matrix composites is developed by pressing the gas. But gas should be neutralized gas. And next will be gas pressure infiltration process. This is the process pressurized gas is used for the infiltration of the metal matrix liquid phase. And this process is carried out in vacuum because of low pressure requirement and inside air of the chamber. This process, industrial, if you want to do the industrial production of the composite, then we can easily use the gas process infiltration process. And next is diffusion bonding. This process is used for binding tightly the matrix and the fiber with the mechanical pressure and the high temperature. And this technique is used for bonding of the long fibers and where hard joining of composite by other methods. If you require a high quality of joining, and that joining is depends on the bonding temperature, bonding pressure, and holding type. That is basically a pressure type development of the composites. If you see the methodology to develop the composites by simple way, the first one is that collect the matrix of the reinforcement material. Two things will be collected from there, matrix and reinforcement material. Then we mix and blend it according to the set parameters. Then we stir cast, if it's possible, maybe stir cast, maybe powder metallurgy route. Here we take in a stir cast. After that, sintering, and that microstructural tensile and tear studies, and after that finished product study the finished product. Next one is the applications of the composites. There is a worldwide demand of the composites is increasing 5% per year, and after the World War II, the demand is increasing day by day. The aircraft assemblies, the biggest consumer of the composites is automobile sector in our country. So in the IC engines, pistons, aluminum bodies, that is the helicopter rotor blades, high temperature devices, marine applications, sports equipment, electronic equipments. These are the applications where we use right now for the composites. And next one is some applications, the figures is here, like in mechanical engineering, the drill bit, and for the army warfare tanks, cycles, and stainless steel bottles or any other materials for use. Now the properties, when we see the properties of the material, it will be comes from density properties. The density is the first is the physical property, which is calculated by that formula. And hardness, tensile, as we know that the hardness is the characteristics of the material to resist the permanent deformation. Micro hardness tests also performed at a 1 kg load with static indentations. Procedures of the testing of the same hardness vehicles. Tensile strength is also very important to decide the composites according to the applications required for industry or any other. Next one is the compressive strength. This is a very important factor for the compressive. It is the American standards we use. And fatigue life, by particular the continuous loading, prolonged loading of the composites. We have also used the fatigue test of the composites. And next one is the references of that. And thank you. Thank you. That is all about the composites and its material.
Okay, thank you, Mohammad Faris. Is there any question from the audience side? Any question from the audience side? I may request Mr. Adil Zadi Saab and Dr. Shamim Akhtar Saab to give his your valuable comments for this paper.
Yeah, nice presentation. The thing is nice one.
Okay, thank you. Thank you very much, sir.
Okay, thank you so much. Thanks a lot. A wonderful presentation by Mohammad Faris Saab. Now we move to the next paper, that is paper ID 1083 impact of parametric variation on the performance of CNET, TEFT and GATE all around GA, FET, Mujib Khan, Gani Nawaz Khan, Dr. Shaheen Khan, Professor Javed Siddiqui.
Hello, am I audible, sir? Hello, sir, am I audible?
Mujib Khan Saab, please wind up your paper in the given period, given time. Show the run the slideshow.
Good afternoon, sir. My name is Mujib Khan, and I am from Aligarh Muslim University, Department of Electronics, and I am pursuing my master's in system design, electronics circuit and system design, first year. So today I am going to present this topic: the impact of parametric variation on the performance of CNT FET and gate all-around FET. So the objectives of this work was to study and describe the modeling of performance of 2D materials like nanowires and CNT FETs, and to examine their electrical properties with the function of the variation in the transistor structure, such as diameters and their lengths. Hence, in this research, we also calculate the current voltage properties for nanoscale single gate FETs using simulation of ballistic transportation and at the multiple channel lengths. The tool we have used in this simulation was the FATTOY, which is open access available on the nanohub.com. So here is the structure of gate all around silicon nanowire field effect transistors. So we already know that downscaling of planar transistor has brought several detrimental effects such as increments of leakage current and short channel effects, and we are at the level that we cannot further decrease the size of channel length in this era. So for that reason, we have a large number of novel structure device which has been proposed in the literature, like we have a 3D MOSFETs and the Schottky barrier MOSFET, and we have for FinFETs and gate all around silicon nanowire transistor, and we also have CNT FETs. So one of them is gate all around transistors, and the structure of the gate all around transistor has been shown in this picture, in which the gate is wrapped uh, uh, which has been wrapped in all the manners from all the sides, and we because of that reason we have a very good control over the channel, so we can control the flow of current inside that channel. So the nanowire could be a better prominent in the field of MOSFETs. So we try to simulate nanowire field effect transistor along with their diametric parametric variations, and we also have another type of transistor which is carbon nanotube field effect transistor. So these type of MOSFET can be built by the rolling the graphene sheets, and the vector at that the sheets have been rolled is known as chiral vector, and CNT the physical structure of CNT FETs are very much similar to MOSFET, which makes its these type of transistor to very much suitable to use in our currently using in foundries. A semiconductor carbon nanotube is inserted between the source and drain as a channel, so the functionality of MOSFET can be achieved with this structure. There are many advantages of the carbon nanotube over the bulk MOSFET or our normal use device in this silicon devices. Like we have a less current leakage in the carbon nanofets, and we have a higher thermal conductivity and higher electrical conductivity, and they are very much of tensiles, and they are very much strengthful. And designing of CNT FET based circuit with fewer number are required. CNT FET reduce the fabrication cost of the electronics and digital circuit. And what we done in this simulation, we have our nanohub FATTOY tools. We have initialized it, and we have done different type of dimensions and vary those physical dimensions. We have electron mass value of 2D material, model parameters and get drain control, and then we have change environmental parametric initial and final voltage, and then we extract some of the IV analysis, design nanowire FET and CNT FET also. So what we have done the simulation for these type of devices. The first one is CNT FET.
and the second one is silicon nanowire. Both looks very much similar, but the major difference between them are the materials. In the CNT FET, the channel is used which is made of the carbons, and in the silicon nanowire, the channel is used on the was made of silicon. So in the simulation result, we have extracted many graphs at different value and different of parameters, and after that we have stabilized them, and here all the graph has been depicted in these pictures. So the graph shows the currents or ID characteristics of the MOSFETs at different channel length and different biasing points. The first graph is shown for the 1 volt, and all the biasing conditions are same for the all type of devices, whether it's a CNT FET or a nanowire MOSFET. So the first 3 graphs is shown for the carbon nanofed, and the last 3 graph has been shown for the nanowire MOSFET. So from these graphs, we can conclude that our CNT FET is showing better results, but to be more specific results and values, I have tabulated all these results in this table, and we can see from the table that at the same diameters and at the same biasing conditions, our CNT FET is showing better results as compared to gate all around FETs. Because gate all around is made of the silicon. The material used to develop this technology is silicon, while to develop the CNT FET, the material is used is graphene. So the results are tabulated here, and we can see from these results that CNT FET are far better than the gate all around FET from the 10 currents, and all the current value are in microamperes, and the diameter value are nanometers. So the result we have extracted for the 1 to 10 nanometers at different diameters. So conclusion, so in this research work, we have simulated both of CNT nanowire and gate all around FET, and we use FET tool for the multiple channel length, and we have observed that the CNT FET yield to be a better candidate at sub 10 nanometer node, because the drain current is directly proportional to the performance of the devices. If the drain current is higher, then the performance of that device will be a better. So from these table and graph, we can conclude that CNT FET yield to be a better in the all areas at drain current, or whether it's leakage current, and maybe other. So this study show that the CNT FET technology has a bright future in the area of wireless RF electronics, or maybe for the digital electronics, or any other branch of the electronic circuit like analog or others. So CNT FETs are discovered to face a variety of challenges even after being identified as a potential competitor in the semiconductor sector, which one of the prerequisite for ensuring dependability being just to be a significant issue what has to be addressed. Or we can say there are some challenges in this technology, that we cannot directly fabricate the CNT FET at the foundries we are currently using for silicon technology, because their structures and their physical dimensions are little bit different from the silicon technology. That's a major issue, and at the same time the cost of foundry is very high, so we cannot
Okay, Zuneeb,
change the factories right now. So, and hence these are my references which I have taken for my study and simulations, and thank you everyone.
Is there any question from the audience side? Is there any question on the paper of Mujib Khan? Thank you, Mujib. Thank you so much. Now we may proceed to the next paper.
Thank you, sir.
Just Mujib, you have to wait. One of the participants want to ask some questions. Please.
Sorry, sir.
Satisfied in the FET also?
Oh, yeah. Yes, sir.
How is it possible?
Your voice. What, sir? No. Sir, your
Can
voice is
gate
not
all
clear
around
actually.
condition can be satisfied transistor?
Sir, your voice is breaking. It's not clear.
Mujib, I just say, can gate all
Yes, sir.
around
Yes,
condition
sir.
can be satisfied in the CNT-FET transistor?
At the level of functionality, like we realize different types of circuits from
Mujib,
the
your
gate
voice
all around.
is not audible. Please speak loudly. Your voice is a
Sir,
bit low.
yes. Hello. Now I'm audible.
I repeat once again, Mujib. Can
Yes, sir.
gate all around condition can be satisfied in the CNT-FET transistor?
Yes, sir.
Can you explain in
Hello.
detail?
Yes, sir. As we realize all the electronic circuit in other technology, we can also realize the circuits in gate all around FET, and at the same time, we can also realize all the electronics and electrical circuit in the CNT FET also. The when we compare both of the technology, so we found that CNT FET showing better results as compared to gate all around, because gate all around is also a successor of previously silicon technology, which we has been currently using, like FinFETs and other 3D MOSFET structures.
Then what will be the effect on the mobility?
So mobility will be higher in CNT FET, sir, because the mobility of electrons in carbon is higher as compared to silicon, sir. So mobility will be higher in the CNT FET.
In case of a gate all around condition for the CNT-FET transistor, then what will be the effect on the mobility?
So mobility of electron will be higher in the CNT FET, sir.
The normal CNT-FET mobility will be lower as compared to the gate all around CNT-FET mobility.
Yes, sir. Because there will be a velocity saturation effect in the all around condition, because we are applying the voltage from all the sides. So
Okay, Mujib, thank you so much. Now we may proceed to the next paper. Paper ID is 1037. Study and simulation of graphene nano-ray burns by Uzma Kaniz, Professor M. Javed Siddiqui, and Muhammad Omar Khan.
Yes, sir. Good morning, everyone. Sorry. Sir, is my slides
Uzma,
visible?
please cover your paper within the limited time frame.
Yes, sir.
Just wait a moment, Uzma.
Yes, sir.
Okay, you may start. Please cover your paper in the limited time period.
Okay, sir. Good afternoon, everyone. I am Uzma Kaniz from Aligarh Muslim University. I'm a student of MTech first year in Electronic Circuits and System Design. My topic is study and simulation of graphene nanoribbons. In my paper, I studied about the graphene and its chemical structure, and about graphene nanoribbons, energy gap, and we did a simulation of various properties like mechanical properties, electronic properties of graphene nanoribbons by using the tool PCAD nanovides, and various synthesis methods, its applications, and its advantages over other semiconductor materials. And we also studied about its future scope. Graphene is a one-atom thick planar sheet of sp2 bonded carbon atoms that are densely packed in a honeycomb lattice. Graphene possesses unique combination of properties, has attracted attention for electronic applications. It is a patternable, scalable, and has demonstrated high mobility and even room temperature ballistic transport. It has pure substance, orderly structure based on tight, regular atomic bonding. Yet graphene is believed to be the strongest material. It has high thermal conductivity and is very light and transparent. Graphene sheets are almost impermeable. The carbon-carbon bond length in graphene is about 0.142 nanometers. Graphene sheets stack to form graphite, and one stack of consists of 3 million sheets, and it is about 1 millimeter thick. Graphene is the basic structure element of some carbon allotropes, including graphite, charcoal, carbon nanotubes, and fullerene. Now, graphene nanoribbons, also called nanographite ribbons. It is a carbon-based material. It is a one-dimensional structure with a hexagonal two-dimensional carbon lattice. It is a derivative of graphene. Graphene ribbons were introduced by Japanese physicist Mecw Fujita. He introduced graphene nanoribbons as a theoretical model to examine the edge and nanoscale size effect in graphene as shown in the figure 2. Various properties of graphene nanoribbons. It is a ribbon form of graphene, and it inherited almost all the attractive properties of carbon nanotube and graphene, like it has high mobility, high electrical and thermal conductivity. It has an additional benefit of tunable band gap. That is, its band gap can be adjusted by applying external voltage. Tunable semiconducting behavior with changing ribbon width. The first band gap measurements are made by Futin-Averroes and Philip Kim. Futin-Averroes gave the theory of high on-off current ratio and large transport band gap at room temperature. And according to Philip Kim, energy gap scales inversely with the ribbon width. We worked on the energy gap of the graphene nanoribbons, how energy gap can be tuned. The energy gap of the one-dimensional graphene nanoribbons can be produced lithographically by patterning two-dimensional graphene through a chemical route. When graphene is patterned into a nanoribbon and the carriers are confined to a quasi one-dimensional system, we expect the opening of an energy gap. Earlier theoretical work showed that this energy gap depends on the width and crystallographic orientation of the graphene nanoribbons, similar to the carbon nanotubes. The first experimental work on GNR has shown that transport gap can indeed be opened up by patterning graphene into nanometer size ribbons or constrictions. Mechanical properties of the graphene shows that graphene is considered as semi-metal because there is no band gap. There is a narrow channel width and a band gap can be provided. GNRs have been predicted to display high electrical and thermal conductivity and high breakdown current density as well, and low noise, which suggests that they can be used as an alternative to copper for integrated circuit interconnects. GNRs shows a band gap that can be tuned by tailoring their width and edge structure. Zigzag GNRs are always metallic, while armchair GNRs can be either metallic or semiconducting. Electronic properties. Zigzag and armchair GNRs are metallic or semiconducting electronic properties that depends on the width of the nanoribbon. Electronic properties depend on the edge shape of armchair and zigzag. Let's discuss them one by one. It is a band structure for armchair type. In armchair edges, each pair of segment is a 120-degree rotation of the prior pair. According to density functional theory, calculations show that armchair nanoribbons are semiconducting with an energy gap scaling with the inverse of the GNR width. Otherwise, armchair nanoribbons are metallic or semiconducting and present spin polarized edges. Their gap opens depends on unusual antiferromagnetic coupling between the magnetic moments at opposite edge carbon atoms. This gap size is inversely proportional to the ribbon width. Zigzag GNR type, this is a band structure of the zigzag type. Zigzag nanoribbons are always metallic. In zigzag edges, each successive edge segment is at the opposite angle to the previous one. Calculations based on tight binding theory predict that zigzag GNRs are always metallic. Here are the various synthesis methods of GNRs. The structure and physical properties of the GNRs vary significantly depending on the synthesis method, and these methods are cutting from graphene using lithography. Lithography process involve the category of nanolithographic techniques through which transistors with smaller features can be patterned. It uses X-rays to transfer a geometric pattern from a mask to a light-sensitive chemical photoresist. And the second method is bottom-up synthesis. In bottom-up synthesis, the structures are assembled from their subcomponents in an additive fashion. And third one is unzipping of carbon nanotubes. GNRs can be produced by unzipping or axially cutting nanotubes. In one such method, multi-watt carbon nanotubes were unzipped in the solution by action of potassium permanganate and sulfuric acid. In another such method, GNRs were produced by plasma etching of nanotubes partly embedded in a polymer film. GNRs are commonly used in the following applications. Since graphene nanoribbons possess semiconducting properties and may be a technological alternative to silicon, semiconductors capable of sustaining microprocessor clock speed in the vicinity of 1 GHz. So it can use in the various type of field effect transistors or diodes like field effect transistors, Schottky diodes, PN junctions, light emitting diodes, solar cell systems, liquid crystals, and in transparent conductive electrodes. The mechanical properties of the two most common graphene nanoribbon, zigzag and armchair, were investigated by computational modeling using density functional theory and molecular dynamics and finite element method. Here are the various advantages of graphene nanoribbons over the other semiconducting materials like silicon. Graphene nanoribbons has many properties that make it ideal for electronic devices like superior electrical conductivity, high charge carrier mobility.
You please conclude your paper and share your work.
Yes, sir. Mobility of graphene nanoribbons is almost 250 times higher than silicon, as we see by the simulation method, and its flexibility and thinness is also very greater than the silicon. Through our research work, we see that GNRs are the promising future models for future electronics due to their unique properties. And if we did the fine tuning of the electronic band of GNR, it will definitely increase its future potential application. Silicon is a synthesis by top-down synthesis, which according to which there is a limit to how far we can etch or lithograph and pattern a silicon material, but we synthesize the graphene nanoribbons according to bottom-up fabrication, and in bottom-up nano fabrication method and nanomaterial creation, we do from scratch as seen in the future of electronics. So we see that according to simulation that graphene certainly has the potential to replace silicon in electronics, and it offers a better value proposition in the long term. These are my references.
Okay, thank you, Uzma. Is there any question from the audience side? Any question from the
Usman, can you give a brief difference between the GNR and the CNT? Can you give me a brief difference between a GNR and the CNT?
Yes, sir. Hello.
Can you give me a brief difference between a GNR and a CNT?
Yes, sir. CNT is basically in the form of a cylindrical sheet, and it's a double layer, and it's a graphene nanoribbons is a one thick planar sheet, and it's in the form of hexagonal lattice, honeycomb lattice. We synthesize GNR
If
from
we
the
just found if we just
graphene.
go with the short channel effects, then the short channel effects will be found in more in GNR or in a CNT?
Thank you, Ms. Uzma, for your very good paper. Now, I may invite the last paper of this session, Simulation paper ID is 1023, simulation and analysis of various types of CNTs by PZ orbital method and length variation, effects on brain currents in CTEPs by Mujib Khan, Professor M. Javed Siddiqui, Muhammad Omar Khan. This is the last paper of this session.
Good evening, sir. And in this presentation, I'm going to present simulation and analysis of various types of CNT by PJ orbital method and length variation effect on drain current in CNT FETs. So,
Mujib, you have a 7 minutes time.
Yeah, okay, sir.
Please
objective-
share your work.
Yeah, okay, sir. So in this research, what we have done, we have varied the channel length of the CNT, and
Please
we
speak loudly.
calculated.
Your voice is not coming.
So in this research work, what we have done, we have varied the channel length in accordance to the different channel length, and we calculated the drain current with the help of the tool freely available in Nano Hub, and we have compared that by decreasing the channel length, the current is also increasing. So from these results, we can conclude that by reducing the channel length, we can also have a better better drain current for our purposes, and we can use that current for the high performance devices and high performance circuits in our circuits. So these are the results which has been tabulated in this table, and for the chirality vector 13,0, and we have shown for the channel length 50, 20, 10, and 7 and 5, and the corresponding drain current is also shown in the adjacent cells. So from the table we can also plot the ID current, and we can see that as we decreasing the channel length, the drain current is also increasing with respect to the channel length. So we can conclude that by decreasing the channel length, the higher value of current can be achieved, so which can be used for in the circuits, like realizing the CNT FET circuits for the higher drain current and high performance circuits. So we have done this work in this research work. We have used the CNT band tool, which is freely available on the Nano Hub. We also have used FETtoy for the simulation of this work. And these are the references I have taken for the study and the research of this topic. Thank you. Any questions, sir?
Okay. This tag is over. I request to Dr. Shamim, chair and co-chair, please conclude this track.
Yes, Assalamu alaikum. Yeah. I can see that so many people are doing work on this extraordinary work, I can say, in the graphene area or all those things. Very good, nice. And I think most of them are student, I guess. That this is very encouraging for me to see that the students are working in this domain. Yeah, nice work also. Thank you.
Thank you, Shamim sir.
Thank you, Shahin bhai.
Because association with you cannot be expressed in words. It will take for me to explain ours, so that only then I'll be able to explain your contribution in my personality and in MECW personality, actually. So we wind up this session, and tomorrow we will be starting with the first half we have 2 more